Jasmine, Assistant Professor, St. Joseph Institute of Technology from CSE Department. In today's class, we are going to discuss about mathematical analysis for recursive algorithm. For solving the recursive algorithm, we are going to consider Tower of Hanoi problem. So, the algorithm for Tower of Hanoi problem is, here we are introducing a function Tower of Hanoi. So initially we need to consider n number of disks. So we need to move the n number of disks from A pegs to the destination C peg using the B as an intermediate node. So let's say consider here you are having three disks. The pillars are named as A, B and C. So initially we are going to consider 3 disks as per this order. So the outcome of this Tower of Hanoi problem is we need to move all the disks in the same order to the destination. Here source disk is named as, source pillar is named as A and the destination pillar is C. So here at the first step, the input for this algorithm is we have considered 3 disks and 3 pegs. Output, we are going to move all the 3 disks from A to C. So in order to execute this algorithm, let's consider if you are having one disk, we need to move the disk from A to C. Else part, we are going to call this Tower of Hanoi problem recursively to move n minus 1 number of disks to the intermediate pillars, and finally we are moving those disks to the final destination pillar. So in else part, we are going to consider Tower of Hanoi problem, Tower of Hanoi function n minus 1. Here the source is A. Initially I need to move n minus 1 number of disks from A to B using the intermediate disk as C. That is, here we are moving n minus 1 disk from the source A to the destination B using the intermediate pillar as C. Again, I need to call recursively n minus 1 number of disks from B to C. Initially we have moved n minus 1 disk from A pillar to P pillar by using C as an intermediate pillar. Here after that we are going to move the destination pillar is here B. From B to C I need to move the n minus 1 number of disks to get all the disks in arranged order as per the input given. So I am calling this function recursively to bring all the 3 disks to the destination pillar. So as per this call, we are moving n minus 1 number of disks from the source B to C by using A as an intermediate node. A as an intermediate pillar or pegs. So this is the algorithm for Tower of Hanoi. So as per this algorithm, if you are having n is equal to 1, we can directly move the disk from A to C, or else we are recursively calling the Taraf-Hanoi problem in order to move n minus 1 number of disks to initially A to B by using the intermediate pillar C. After that, I am moving n minus 1 number of disks from B to C by using the intermediate pillar A. So this is the first step we have performed by calling the Tower of Hanoi for n minus 1 number of disks. So this is the outcome we are getting while you are calling this function recursively. After that, we need to move this n minus 1 number of disks from B pillar to C by considering the intermediate pillar as A. So here, while we have this state as a scenario, here you are having n is equal to 1. Here I am having only one disk in this source pillar, so directly I can move from A to C. So we have moved the disk from A to C. After that, I need to have n minus 1 number of movement from B to C to make the output here. So initially I need to consider at this point I am moving the smaller disk from B to A. Then I need to move the intermediate size disk from B to C. Then I have to move the small size disk from A to C. Finally, we are getting the disk arranged in the output pillar. So this is the algorithm for performing recursive mathematical analysis. So here we are going to calculate the mathematical analysis time complexity for Taraf-Hanoi problem. So for this, we need to consider certain rules. So the rules are, for the mathematical analysis for recursive problem, we should consider certain rule. The first rule is, first we need to identify the input size. Second step, we need to consider the basic operation to be performed to solve this problem, basic operation. At the third step, we need to identify how many number of times this basic operation has been performed. So at the fourth step, since this is the recursive algorithm, we have to write the recursive relation. We have to write the recursive relation. At the fifth step is, we need to apply some forward or backward substitution method to bring the time complexity of this recursive problem. Apply forward or backward substitution. So these are all the general rules for analyzing the time complexity for recursive algorithm. Here these are all the certain rules. First we need to identify the input. Then what is the basic operation is performed to execute this algorithm. Then the third step is number of time those basic operations are executed. Fourth is recursive relation. And fifth is we have to apply some forward or backward substitution to bring the time complexity. So here we are going to consider all these rules for the same problem. So that is Taraf-Hanoi. Here initially we need to identify the input size. As per the data given, the input is, we are considering 3 disks. 3 disks is the input. So n disk we have considered here. Then basic operation is performed for this problem is movement. We are moving the disk from one pillar to another. So move operation is performed. So the number of time basic operation is executed is here 2 n minus 1 call we are performing to execute this operation plus 1 movement. So this is the number of time the basic operation is performed. Finally, we need to consider the recursive relation for this Taraf-Hanoi problem. Here the recursive relation we can consider m of n is equal to 2 times m of n minus 1 plus 1. Okay. So here why I have written this recursive relation m of n is equal to 2 m of n minus 1 is, in this recursive call, while I am calling this function, n minus 1 number of disks gets moved from A to B by using the intermediate disk C. That's why 1 n minus 1. After this process, again I need to execute n minus 1 number of disk movement from B to C. So 2 times n minus 1. That's why 2 of m of n minus 1. If n value is 1, we have to move the disk from A to C. So that's why I have given plus 1. By this way, we can write the recursive relation for this problem. So after that, we are going to bring the time complexity from this recursive relation by substituting forward or backward substitution method. Let's see those process here. So let's consider the recursive relation for this Taraf-Hanoi problem is m of n is equal to 2m of n minus 1 plus 1. So here we are going to apply backward substitution method. So here, by using backward substitution method, we need to calculate the term m of n minus 1. So we need to find the value of m of n minus 1. So this is the initial statement, this is the recursive relation. Here instead n, I need to substitute n minus 1. So while I am considering that 2 of, we can calculate it here, m of n minus 1 is equal to, just you need to apply this equation here, instead n we need to substitute n minus 1. So 2 of m, instead n I have given n minus 1 minus 1 plus 1. So I will be getting 2m n minus 2 plus 1. This is the value of m of n minus 1. I can take this to substitute in this equation. So here you will be getting 2m n minus 2 plus 1 plus 1. So while I am multiplying this 2 to the inner term, we will be getting to the power 2 m n minus 2, then to the power 0, that is 2 into 1 2 plus 1. Again, in order to apply, in order to derive, again I need to substitute the value of m of n minus 2. Here instead n I need to substitute n minus 2 value. So 2 of m, 2m of n minus 2 minus 1 plus 1. We will be getting 2m n minus 3 plus 1. So this is the answer for this term. So I need to substitute the same term here to the power 2. Instead m of n minus 2 I have to write this term. So 2m n minus 3 plus 1 plus 2 plus 1. So while I am multiplying the inner term, you will be getting to the power 3 m n minus 3 plus to the power 2 plus 2 plus 1. Again, if you are substituting the terms to the power 3, instead m of n minus 3, I need to again place the value for m of n minus 3 to the power m n minus 3 minus 1 plus 1. So 2m n minus 4 plus 1. This is the answer for this term which we are going to substitute in this equation. So here you will be getting 2m n minus 4 plus 1 plus to the power 2 plus 2 plus 1. So while I am multiplying, we will be getting to the power 4 n minus 4 plus to the power 3 plus to the power 2 2 plus 1. So likewise we can apply the backward substitution method. So after that again I need to derive it like this. So it will go zone like this. So we need to bring the general equation from this term. So when you look at this equation, here instead 4, here we are having 4, at the next step we will be getting 5 here. So this value gets changed in each and every step. So we need to bring the general equation for this. So instead the variable terms we need to give to the power k m of n minus k plus to the power k minus 1. This is k the power here 3. So I can give here, I have mentioned instead of this value I have given k, so this is k minus 1 plus to the power k minus 2, like that it will go. So this is the general term, but in this step we need to consider the recursive relation with some initialization. So here we have to write the recursive relation with initial statement. So initial condition is m of 1 is equal to 1. M of 1 is equal to 1. So I need to bring this term as 1. So instead k value I need to substitute n minus 1. If I am substituting n minus 1, you will be getting m of 1 here. I can easily replace it by 1. Okay, so that's why I am substituting here to the power k. Instead k I need to write the value n minus 1, n minus 1. Here also m of n minus, instead k I have to write n minus 1. Then only I can bring this term as 1. I can easily derive the time complexity. So here instead k I need to bring n plus 1. If I am substituting n minus 1, so minus gets multiplied with this term. So n minus n plus 1 will be getting. So plus to the power, if I am substituting n minus 1 in this term, I will be getting n minus 1 minus 1. So that is n minus 2. Then to the power n minus 1 minus 2, that is minus 3. Like that, 2 plus 1. So this both term get cancelled. You will be getting to the power n minus 1 m of 1 plus to the power n minus 2 plus 2 n minus 3 plus 2 plus 1. So as per the initial condition given in this recursive relation, we need to assign recursive relation with some initial condition. So here the minimal cases n equal to 1. If you are having n is equal to 1, we can easily move the orders from A to C directly. So m of 1 is equal to 1 here we have considered. So after substituting we are getting this value. So again I am continuing this step here. So while I am substituting to the power n minus 1, this value become 1 because m of 1 value as an initial condition the value is 1. So plus to the power n minus 2 plus to the power n minus 3, like that. Here this term become n minus 1 plus to the power n minus 2 plus to the power n minus 3, 2 plus 1. As we all know, in this mathematical representation, we'll be having one equation like to the power 0 plus to the power 1 plus to the power k can be replaced by to the power k plus 1 minus 1. So this is the formula to replace this expression. So when you see here in this, instead k, here we are having n minus 1. So we have to substitute this in this equation. So to the power, instead k, you will be having n minus 1. So instead k, I need to substitute n minus 1 plus 1 minus 1. So both terms get cancelled, to the power n minus 1. This is the constant term. So I can remove this. No need to consider the constant term while we are calculating the time complexity. So here this is to the power n. So the time complexity for this recursive problem is theta of to the power n. Next here we are going to solve another one recursive problem. We are taking to analyze the mathematical time complexity. As we know, this is the general plan for mathematically analyzing the recursive algorithm. As a first step, we need to decide the input size. Okay, here we have considered an algorithm as factorial of an element. This is the algorithm. As the recursively we are calling the function factorial in order to find the factorial of an element. Here we need to decide the input size. At the next step, we need to identify the basic operation. Third step, how many number of times the basic operation is executed. The fourth step, we need to set up the recursive relation with some initial condition. At the fifth step, we need to apply some forward or backward substitution method to bring the time complexity. So as in this algorithm, if well you are going to find the factorial of an element, if I am taking a factorial of element 4 factorial is equal to 4 into 3 into 2 into 1. So this is the initial assignment. So the value is 1 here. So while you are calculating this, as per this rules given, decide the input size. So input size is n. Okay, so which element we are going to calculate the factorial. Then identify the basic operation. As per the statement given, the basic operation in this expression is multiplication. So here, in order to calculate the 4 factorial, well I am calling the 4 factorial, so 4 into 3 factorial. I am calling the 3 factorial again in order to calculate the total factorial value of the element 4. So likewise, the term get calculated recursively in order to bring the factorial of an element. Then here, as we know, as a fourth step, we need to set up the recursive relation with some initial condition. So here the recursive relation to for finding the factorial of an element is f of n is equal to, so f of n minus 1 into n. So the initial condition here we need to assume is f of 0 equal to 0. This is the initial condition. So in fourth step, we need to set up the recursive relation. The recursive relation is named as the f of n function equal to, so as per the statement given, we need to bring the initial condition expressing the basic operation. Here the basic operation we found in the second step is multiplication. Multiplication is the basic operation. So we are bringing the expression to expressing the basic operation multiplication. So f of n minus 1 into n, I have written here, this is the recursive relation. This is the initial condition for solving this problem. So at the next step, we need to recursively apply forward either backward substitution method to bring the time complexity. So here I am going to consider the relation. Since this is a multiplication, I have rewritten as m of n. M of n is equal to m of n minus 1 plus 1. So here, while I am considering this, 4 factorial gives this expression 4 into 3 factorial. 4 into 3 factorial. So here 1, 2, 3, 4, 4 multiplication I need to perform for 4 factorial. So here m of n minus 1, that is 3 factorial into 1 term. I am going to add this multiplication as one more value, right? So that's why I have given plus 1. One more multiplication I have added with this 3 factorial. If you are calculating 3 factorial, I need to bring 3 multiplication operation. In order to bring the 4 factorial, I need to add one more multiplication. That's why I have represented the mathematical expression like this, m of n minus 1 plus 1. Here, so in order to solve this, I need to apply the backward substitution. I am going to apply the backward substitution here. So backward substitution, I need to derive the term m of n. For that, I need to calculate m of n minus 1. So instead m minus 1, instead n value, I need to apply n minus 1 over here. So here m of n is equal to m of n minus 1. So instead the value n, I need to apply n minus 1. So m of n minus 1 minus 1 plus 1. So m of n minus 2 plus 1. So I need to apply the value here in this recursive relation. So m of n minus 2 plus 1 plus 1. So the answer is m of n minus 2 plus 2. Again I need to substitute the value of this term. So I can calculate it here separately. So m of n minus 2. So here this is the general equation. So instead n, I have to substitute n minus 2. So while I am substituting n minus 2, I am getting n minus 2 minus 1 plus 1. So m of n minus 3 plus 1. This is the answer. I need to bring it here. So m of n minus 3 plus 1 plus 2. Okay. So 1 plus 2 is 3. So this is the general equation. So at each time, at the next if you are calculating the value, so it becomes 4, then 5 like that. So these two are the variables. So I can generally written this expression as n minus, I can replace any general value. So I can bring it here I plus I. In order to calculate the time complexity, so I need to bring this term to satisfy the initial condition. We all know m of 0 is equal to 0. This is the initial condition I have taken while I am representing the fourth step. So here m of n minus 1, n minus I. Instead I need to bring the value n minus 1. I have to bring I equal to n. While I am substituting n here, both get cancelled. M of 0 plus I. So while you are bringing this, m of 0 value is 0. Because m of 0 is equal to 0 as per the initial condition. So 0 plus n. While I am calculating the time complexity, we should not consider any constant value. We need to consider the value with the term n. So from this we can say that the time complexity for solving the factorial theta of n. Thank you.